Hello all my JavaScript friends, this is TheVirtuoid, aka Mike Smith, and this is our snake game. Now before we start showing you code, we're going to be producing two videos that will kind of explain the concepts that we're going to be using in coding our snake. And it's going to be very important that you understand how these particular concepts work. So let's take a look at the very first one, and it all deals with the snake. Now with the snake itself, we're going to be splitting the snake up into different pieces. For instance, in this particular example, we're going to be splitting the snake up into a head and into a body. And then we're going to be splitting the body itself up into different little segments. In this particular case, for the purposes of this illustration, 5 segments. And this is very important because if you think of a snake as it moves along the ground, the head may be going one way, but pieces of the body will be undulating differently depending upon where the piece previous was going. So if the piece next to the top of the head will be going about the same direction of the head, but the piece at the tail may be going in the direction that's, the piece that's on the other side of the tail. So it would be very important for us to be able to know where the head is and where all these different segments are. And because of that, the most important data for the head and the segments are position and direction. Without those two pieces of information, our snake gets completely lost. But with just those two pieces of information, we can have our snake be anywhere at any time. And how are we going to represent all this information? By using vectors. Now, what is a vector? Well, now in mathematical terms, a vector is basically as a function of a magnitude and a function of a direction. But in our particular case, we're going to be using vectors as representing basically coordinates, a coordinate type system. Now, in our particular case here, the vector is going to specify 3 different types of coordinates. A location in space, like, row 5, column 5, row 10, column 3, things like that. A direction, which we'll get to a little bit later here, well, actually, next slide we'll get to. And the dimensions of an object, for instance, it's 10 rows by 10 columns or whatever. A vector can also represent a 2D vector, which has XY coordinates, a 3D vector, which has XYZ coordinates, and a 4D vector, which has XYZA coordinates, a 5D vector, which may have XYZAB, a 6D vector, which has XYZABC, and so on and so forth. You know how that is. But in all, it's all still just vectors. So, where a vector, a location for a vector, so a vector specifying location is easy to understand, and a vector specifying dimensions is easy to understand. Well, what about direction? Let's take a look at directions. A property within a direction vector will have the numbers between -1 and 1 inclusive. Now, what does that really mean? The idea here is that the snake is going to be moving at a particular speed, and the direction vector is going to tell us what direction it's going to go in that speed. So, for example, if the snake is to move to the left, then we will have a direction vector of -1, 0. That basically means we multiply the speed by the x, which is -1, and we multiply the speed by y, which is 0. And so that will give us, whatever the negative speed, comma, 0. So for instance, if our speed is 2, then we're going to be moving the snake 2 places to the left, or -2, 2 places to the left on the x-axis, but 0 on the y-axis. Same thing with upwards, for example. We will have a x of 0, so 0 times speed is 0. -1 times speed is negative whatever the speed is, in this case 2. Downwards will be 0, 2, and right will be 2, 0. So in this case, we use the direction vector to be able to specify how far we're going to move based upon the speed along the x or the y-axis, or in a 3D vector or z-axis or whatever. Now, can these vectors, can we send it to both directions at the same time? For instance, right now we just have it going either left, right, upwards, or downwards. But how about, both left and up or whatever? Well, of course, yes, we can. So for instance, if you want to go to the left and up, this will be a -1, -1. Or if you want to go right and down, this will be a 1, 1. So again, we take our speed, multiply it by the x, and our speed, and multiply it by the y, and get what we want. And this works out great for a grid type pattern, which is one of the first things we're going to look at here. But if we're also in a 2D type pattern where we don't have a grid, everything is nice and fluid, that number can be between anywhere between -1 and 1. So for example, if we want to go kind of to the west, then or kind of left, then our left axis may be -0.862. Or if we want to go a little bit to the right, it may be or a little bit just off to the top, it may be 0.16 or something like that. So by having the numbers as -1, 2, 1, we can specify it to go any direction whatsoever, either up, down, left, or right, or depth or pitch or whatever the Z factor is on the for 3D. So let's take a quick look at what this will look like within a particular snake. So here's my snake again. I've got the head and the 5 segments. The head starts off at position 10, 10 with a direction vector of -1, 0. That means it's going to be moving to the left where we can apply to it. The second one, the second position, or second segment, or the first segment actually, is going to be at position 11, 10 with a direction of -1, 0. So it's going to follow the head. This next one's at 12, 10 with -1, 0. Next one's at 1310 with a -1, 0. Next one's at 1311 with a 0, -1. What does that mean? That basically means that it's actually going to be moving upwards while everything else is moving to the left. That means we obviously have some sort of bend inside the snake. The last segment is at 1312, also going in a direction of upwards, 0, -1. What does that look like on a grid? It looks exactly like this. So here's the head. It's in red, and I'm sorry for y'all who are red-green colorblind. My apologies. I just suddenly realized that, but sorry about that. So the head is right smack in the middle at 10, 10. It's got a direction of going to the left. Here's that segment right there, that fourth segment. It's actually going to be going up. And the reason it's going up is it's got to follow the segment before it. The segment before it is at position 1310. So with it at position 1311, it's got to go upwards. So that's why the direction vector is 0, -1. So each segment follows the segment before it. And when that happens, you get this once we apply a movement to it. See how that worked? Let me just bring the other one back. Oops. Let me just bring the other one back. And then forward, back, forward, back, forward. You see how that's changing? And what's also important here is that it's the direction vector is also telling us, or telling the segment, which way to go. So when we start off here with direction, or with the fourth segment going upwards, once it moves back into the old position of the third position of the third segment, but it also inherits the direction of that third segment. So once the snake moves, no matter what position it's going to be in whatever direction it moves, it will always inherit the direction vector of the piece before it. So our first segment inherited the head, our segment inherited the first, the third inherited the second, the fourth inherited the first, the fifth inherited the fourth, and the old fourth one was 0, -1, so it is still at 0, -1. So you end up with this. Isn't that neat how that works? So that's why that is very important to understand, is that the vectors in dealing with the position and the direction will always give us absolutely everything we need to be able to move the snake along. So you have to understand position and direction, or everything is going to get lost, because everything deals with position and direction. So that's our first video in explaining position and direction. We'll have another video explaining another concept that we will have for the game, and then we'll start the coding.